Hello, I'm the awesome tutor, and today we're going to be looking at crude oil and fuels. Crude oil is a fossil fuel and a mixture of hydrocarbons. Now, what's a fossil? A fossil is organic matter from millions of years ago. A fuel is something that burns to release energy. So you burn it to release energy. And this energy usually comes in the form of heat, thermal energy. What's a hydrocarbon? A hydrocarbon carbon is a compound of hydrogen and carbon. That's obvious. Hydrogen, carbon. But a compound of hydrogen and carbon only, nothing else. Now for carbon, there's always 4 bonds per carbon. Always. And for hydrogen, it's always 1 bond per carbon. Per hydrogen, sorry. Here's an example. This is methane. As you can see, 4 bonds per carbon and 1 bond for each hydrogen. Fractional distillation. Okay, so we said that crude oil is a mixture of hydrocarbons. So how do we separate out that mixture? By a process called fractional distillation. A fraction is just a group of hydrocarbons with a similar number of carbons. So crude oil is basically a mixture of different fractions of hydrocarbons. We want to separate out those fractions by fractional distillation. Fraction, group of hydrocarbons with similar number of carbons, and distillation, evaporation and condensation. What if they give you a 6 marker on fractional distillation? What are you going to do? Here are the points you need to say to get those full marks. Crude oil is heated. There's your first mark. And vaporized. There's your second mark. Or evaporated. Hot vapors rise up the fractional column. Why do they rise up? Because they're hot. Warm air always rises. There is a temperature gradient. Hot at the bottom and cold at the top. The vapors then cool and condense. Remember, this is fractional distillation. So there's going to be distillation taking place. You vaporize them and then you condense them. And different fractions condense at different boiling points. And this has to do with the number of carbons they have. The longer the chain of carbons, the higher the boiling point. The smaller the chain of carbons, the lower the boiling point. And that's how this process works. That's how they're separated. But we're going to talk about that more later. So here we have a diagram of a fractional column. Okay, so there is a temperature gradient, first of all, as I said, from the 6 marker when we talk about fractional distillation. Hot at the bottom, cold at the top, as you can see here. You have to remember that. Hot at the bottom, cold at the top. At the top of the fractional column, we extract hydrocarbons that are smaller chain length, have a smaller chain length, smaller molecules, as you can see here. At the bottom, we extract longer molecules, and you would naturally assume that the longer molecules have a higher boiling point, and yes, they do. So at the bottom, the hydrocarbons that we extract at the bottom have a higher boiling point. The hydrocarbons we extract at the top have a lower boiling point. However, the hydrocarbons at the top, these small molecules, they ignite more easily. Whereas here, they do not ignite as easily. Let's talk about viscosity. Viscosity is just basically thickness. That's what it means. Thickness of the oil, thickness of the hydrocarbon. At the top of the fractional column, the hydrocarbons we extract are less viscous. As we go down, they're more viscous. You could also talk about how volatile the hydrocarbons are. At the top of the fractional column, they are more volatile. At the bottom, they are less volatile. What does volatile mean? It's how easily it evaporates. The tendency of the substance to evaporate. So the smaller chains of hydrocarbons, they have a bigger tendency to evaporate. They evaporate more easily. You have to know this. You have to know the differences between the hydrocarbons at the top and the hydrocarbons at the bottom. So if you want me to go through that again, rewind the video because I'm going to move on. Okay, before we go any further, you need to know what is the difference between an alkane and an alkene, because students usually muddle them up. An alkane is a hydrocarbon with a single bond. Single bonds only, such as these hydrocarbons. An alkene is a hydrocarbon with a double bond, like that. Alkenes are unsaturated. What does unsaturated mean? It means you can add something to the double bond, whilst alkanes are saturated. Now there are a couple of examples of alkanes which you are required to know and draw the stick diagrams for, which they might ask you to do in the exam. Remember, carbon, there's always 4 bonds per carbon, and for hydrogen, 1. Here we have methane. How do we know it's methane? Because it has 1 carbon. 1 carbon, meth. Meth means 1. Ane, alkane. Next, 2 carbons, so it's ethane. Eth means 2 carbons, ane, alkane. 3 carbons, propane. Prop means 3 carbons, ane, alkane. Last one, butane. 4 carbons, so bute means 4, ane, alkane. If they ask you to draw the stick diagram of one of these alkanes, you have to know how to do it. So as I said, 4 bonds per carbon, 1, 2, 3, 4. And 1 bond per hydrogen. So it's actually not that complicated. Now here we have CH4. Ethane is C2H6. Propane is C3H8. And butane is C4H10. You need to know the chemical formulas for the alkanes. There's a trick to get them quickly. For alkanes, you count the number of carbons, and the number of hydrogens is the same as the number of carbons, but doubled, and you add 2. 1 carbon here. Double it, 2. Add 2 to it, 4. There's your H4. Ethane, 2 carbons. Double 2 is 4. Plus 2 gives you 6. Butane, 4 carbons. Double 4 gives you 8. Plus 2, 8 plus 2 gives you 10. So that's a handy trick to use to get the formula for the alkanes. Next, okay, so combustion. Why have we been talking so much about hydrocarbons? Why do we need hydrocarbons? What do they do? They are fuels. We use them as fuels. How do we get the energy from the fuels? Because that's why we use them. We need energy. We burn them. And when they are burned, they release energy in the form of heat. There are 2 types of combustion: complete combustion and incomplete combustion. In complete combustion, we have a hydrocarbon, in this case, methane, and we burn it in air so that it reacts with oxygen to give us carbon dioxide and water. That's the general equation for complete combustion. Now, incomplete combustion. Here is our hydrocarbon again, which is methane. Burns in air to react with oxygen to give us, this is not carbon dioxide, has 1 oxygen, so it's carbon monoxide. And carbon and water. In this case, the carbon produced, we call it soot. When does incomplete combustion happen? Because there is a lack of oxygen, or not enough oxygen. That's how incomplete combustion happens. Now, carbon monoxide, that's a very dangerous gas. It's poisonous. If you breathe it in, it replaces oxygen in your body, and so you're gonna die. Very slowly. You'll feel sleepy, and then you'll die. And water obviously is produced. Now, this is just a general equation for incomplete combustion. It's not like this for all hydrocarbons. For example, propane in which case carbon is produced instead of carbon monoxide and water. Next, okay, last part, pollution. When we burn hydrocarbons, we release pollution to the atmosphere. Carbon dioxide is a greenhouse gas, leads to global warming, sea levels rising, habitat change, ice caps melting, polar bears have nowhere to live. Carbon monoxide, as I said, is a poisonous gas and harmful in enclosed spaces. Soot and smoke particles from incomplete combustion, they release into the atmosphere and they cause global dimming, which is basically the blocking of sunlight. If you go to an industrial city in China, you'll know what I mean. You've got like a thick black cloud above your head. Now, the main pollutants that the exam board loves to ask you about are sulfur dioxide and nitrogen oxides. First of all, where do you get them from? You get the sulfur dioxide. Well, first of all, the sulfur comes from the fuel itself as an impurity. And then it reacts with oxygen when it burns. When you burn the fuel, it reacts with oxygen from the air to give you sulfur dioxide. Nitrogen oxides, say, in a car engine. A car engine gets really hot. And so it gets so hot that nitrogen from the air reacts with oxygen to give you nitrogen oxides. Why are these two gases so bad? Because they react with water to form acid rain. There it is. So if the exam board asks you about a negative effect on the environment from sulfur dioxide or nitrogen oxides, you can say it reacts with water to give you acid rain. And acid rain is bad because it kills trees, kills plants, because it can lead to formation of acid lakes. Okay, acid rain is very bad for trees. Do not say corrodes buildings, because that's not an environmental effect. If they ask you, why is this so bad for buildings made of limestone, then you can talk about corrosion. Bye!